Have you ever looked up at the night sky and wondered, how did it all begin? As humans, we are naturally curious creatures. Over the centuries, this curiosity has driven us to explore the world around us and beyond. From the earliest astronomers who charted the stars to the modern scientists who probe the depths of space and time, our fascination with the universe has been unending. Indeed, the universe is a complex and mysterious place. Its vastness is incomprehensible, its origins shrouded in the mists of time. Yet we have sought to unravel its mysteries, to understand its workings, and to fathom its inception. This enduring quest has given birth to the field of cosmology, the study of the universe and its origins. Our understanding of the universe has grown exponentially, yet we are still left with more questions than answers. But fear not, for it's time we embark on a journey back in time, back to the very beginning of everything. Most scientists propose that the universe began with what we now call the Big Bang, a concept that has shaped our understanding of the cosmos and our place within it. The Big Bang theory suggests that the universe originated from a single, infinitely dense point known as a singularity. It's a concept that challenges the human mind, as we're used to thinking in terms of space and time. But at the moment of the Big Bang, neither existed. Imagine, if you will, everything you know, everything you see, and everything you can't see. All the stars, galaxies, and vast stretches of space, compressed into a single, infinitesimal point. Then, in an instant, an explosion of unimaginable energy and heat. This was the Big Bang, and it created not just matter and energy, but the very fabric of space and time itself. In the first few moments after the Big Bang, the universe was an incredibly hot, dense soup of particles. It was so hot, in fact, that particles of light, or photons, couldn't travel freely. They were constantly being absorbed and re-emitted by the particles around them, making the universe a foggy, opaque place. As the universe expanded, it began to cool, and the particles started to come together to form the first atoms. But that's a story for another scene. What's truly mind-boggling about the Big Bang isn't just the idea that the universe sprang from a single point. It's the speed at which it happened, faster than the blink of an eye, faster than a heartbeat, faster than the speed of light. In less than a second, our universe was born, but it was far from the universe we know today. It was a place of chaos and energy, a place where the rules of physics as we understand them were being written, and it was the beginning of a journey that's still unfolding, billions of years later, in the vast, beautiful cosmos that surrounds us. As the universe cooled down, it started to take shape. Picture a world, not in the traditional sense, but in a cosmic one. As the universe expanded, it also cooled. This cooling process is like a cosmic chill, a vast and gradual diffusion of energy that allowed the universe to transform from a hot, dense state into a cooler, more spacious environment. In this cooling universe, something extraordinary started to happen. Particles, which had been whizzing around in a chaotic dance, began to slow down. They mellowed out, settling into a slower rhythm that allowed them to come together and form atoms. This is a bit like a cosmic meet and greet, where particles that were once too energetic to interact now had the opportunity to come together and form something new. And what were the first atoms to grace the universe? Hydrogen and helium, the simplest and lightest elements. These two elements are like the universe's firstborn children, the pioneers in a vast expanse of nothingness. Hydrogen, with just one proton, and helium, with two, were the perfect candidates to kickstart the universe's atomic journey. Why? Because simplicity was key in these early stages. The universe was still a young, chaotic place, and it was these simple, light elements that could survive and thrive in such conditions. With the formation of these atoms, the universe was ready for the next stage, the creation of stars. The universe was now a sea of atoms, but how did these atoms become the stars and galaxies we see today? Well, the answer lies in one of the most fundamental forces of nature, gravity. This invisible force has been at work since the very beginning, acting like an unseen hand, pulling and shaping the universe as we know it. Imagine the cosmic sea of atoms, floating aimlessly in the vast expanse of space. Gravity began to pull these atoms together, causing them to clump and form dense pockets of matter. As these pockets grew denser and denser, their gravitational pull became stronger, attracting even more atoms. In the heart of these dense pockets, something extraordinary happened. The pressure and temperature rose so high that atoms began to fuse together, releasing tremendous amounts of energy. This process, known as nuclear fusion, was the spark that ignited the first stars. These stars were colossal, much larger than the stars we see today, and they burned at an incredible rate, shining brightly in the early universe. But stars were not lone wanderers. They began to group together, forming vast clusters. These clusters, drawn to each other by their mutual gravitational pull, began to rotate and shape themselves into what we now recognize as galaxies. Each galaxy, a swirling dance of stars, gas, and dust, held together by the very force that sparked their creation: gravity. These galaxies continued to evolve and grow, colliding and merging, shaping the cosmic landscape. Over time, galaxies grouped into clusters, and clusters into superclusters, forming a vast cosmic web of stars and galaxies, a testament to the power of gravity and the majesty of the universe. Over billions of years, the universe filled with countless stars and galaxies, but what about the planets and life itself? Stay tuned as we delve further into the fascinating journey of the universe's evolution. From the dust of dead stars, new worlds began to form. Isn't it fascinating how the universe recycles itself? The remnants of a dying star scattered across the cosmos don't just fade into obscurity. They become the building blocks of new celestial bodies, planets like our very own Earth. The formation of planets is a process that unfolds over millions of years. Imagine a cosmic dance where particles of dust and gas, remnants from the death throes of stars, start to gravitate towards one another. As these particles collide and stick together, they gradually form a disk of material orbiting a newborn star. Over eons, these particles continue to collide, merge and grow, birthing planets from the cosmic dust. Now let's talk about life. It's a complex and intricate phenomenon that requires very specific conditions to exist. A planet needs to be in the so-called Goldilocks zone, a region around a star where conditions are just right. Not too hot, not too cold, for liquid water to exist. Then there's the matter of having the right chemical ingredients for life, like carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Earth, our home, fits this bill perfectly. It's in the perfect position in relation to the sun. It has water and the right mix of elements. But here's a thought to tickle your curiosity. What if Earth isn't unique? With billions of galaxies, each housing billions of stars, the odds seem pretty good that there are other planets out there in their star's Goldilocks zone with the right mix of elements. The potential for life elsewhere in the universe is a tantalizing prospect, one that scientists are actively exploring. From a singularity to a universe teeming with galaxies, stars, planets, and life, that is the story of our universe. From the humble beginnings of cosmic dust to the complexity of life as we know it, this is the grandeur of our cosmic journey. Our journey through the universe's history ends here, but the exploration of the cosmos continues. We've traversed from the enigmatic Big Bang through the formation of atoms, stars, galaxies, and even life itself. Yet our understanding of the universe is ever evolving, as new discoveries constantly reshape our knowledge. Each revelation, from the smallest atom to the largest galaxy, illuminates our path further into the unknown. As we peer into the cosmos, we not only discover new wonders, but also uncover more questions about our beginnings and our place in this vast universe.